This is a quadratic function, line being tangent to a quadratic function. So quadratic function f is written in intercept form. Fx is equal to a x minus p close brackets x minus 3 in another bracket. The graph of f has axis of symmetry at x is equal to 2.5 and the y-intercept is 0, comma minus 6. Find the value of p. Now if you clearly understand, this is your two intercept form. So in your two intercept form, your x-intercepts, this will give you the x-intercepts. So your x-intercepts here are p and 3. So if I draw my x-axis, my x-intercepts are p and 3. And the axis of symmetry is x is equal to 2.5. So this is the axis of symmetry, x is equal to 2.5. And the y-intercept of this graph, so this graph is there, it cuts the y-intercept. The y-intercept, so this is the x-axis, this is the y-axis. It cuts the y-axis at minus 6. Okay, so it may be upside down then. So that means my graph, if it's cutting at minus 6, that means this graph is supposed to be upside down. This is find the value of p. So first to find the value of p, I'll use the midpoint formula. If your axis of symmetry is x is equal to 2.5, then this is 2.5. So I'll use the midpoint formula, x is equal to x1 plus x2 over 2. 0.5 is the midpoint of p and 3. So 5 is equal to p plus 3. So p is equal to 2. That's the answer for part A. Part B, find the value of a. You've been given the y-intercept. So basically now my equation becomes your fx is equal to a, we don't know. We got the value of p as 2 and we got this as, this is already given x minus 3. Now 0 comma minus 6 lies on it. So this is x and this is fx. You substitute. So minus a, 0 minus 2, 0 minus, I'm putting x as 0. So minus 6 is equal to a, 6a basically. So a is equal to minus 1. So a is equal to minus 1 and p is equal to, this is part B. Now the main part is your part C, in which you need to find out, you have to find the value of k, values of k, so it's a product, correct? If this is, if y is equal to kx minus 5 is a tangent to the curve. Now remember that whenever you are working with the tangents, or you have a parabola and you have a line which is tangent, so what you need to do is you need to equate and you need to work with the discriminant. So in this case your b square minus 4ac is equal to 0, because you will get equal solutions, because if it's tangent means the line is touching the parabola at one point only. That means your quadratic that you get by equating the two equations should have the discriminant b square minus 4ac. So if it's cutting at 2 points, then your b square minus 4ac will be greater than 0. If it's not touching at all, then your b square minus 4ac is less than 0. Now this is a very important thing to remember. In IB they love asking this. They love asking this. So when it's tangent, b square minus 4ac is equal to 0 of the equation that you, of the quadratic equation that you get by equating them. So step 1, I'll equate the line with the parabola. So my line is kx minus 5. My parabola is, now I got the value of a is minus 1, x minus 2, x minus 5. I'll expand it. So this is x square minus, so my parabola is minus x square plus 5x minus. I'll equate them because you have to see where they intersect. So kx minus 5, that's my line, is equal to parabola minus x square plus 5x minus 6. Get all terms on one side. X square minus 5x plus kx minus 5 plus 6. So my quadratic is x square plus k minus 5x plus 1. This is very important. You arrange your equation in ax square plus bx plus c. Now what you need to do is, for this quadratic equation, since it's a tangent, b square minus 4ac is equal to 0. So if it's a is equal to 1, a is the coefficient of x square, b is the coefficient of x, which is k minus 5, and c is equal to 1. So b square minus 4ac, so b square minus 4ac square minus 10k plus 25 minus 4 is equal to 0. I expanded it, nothing else. So this is your k square, right, plus 21 is equal to 0. k, so factorize it, 7 3s are 21. Right? So these are my two solutions for k. So what I'm doing in this case is, to find the value of p, we are using the two intercept form. We have the two intercepts, my intercepts are p and q, and your axis of symmetry is the midpoint. So I use the midpoint formula with the x coordinates and got the value of p. To find the value of a in part b, what I did is substituted 0 minus 6 in the equation of the parabola in part b, if you see. Correct? I substituted it here and I got the value of a. And for the last part, which is very, very important, what I did is, if it's a tangent, when you equate them, the resulting coordinate should have, quadratic equation should have b square minus 4ac is equal to 0. That's how we do it.